Okay, identify the hybridization. This is a very basic question you will see in the exam. Okay, tell me what is the hybridizations here? Simple. This one. SP, how many sigma bonds? One sigma bond and one lone pair. This one, one sigma bond here, one sigma bond here. Don't consider pi bond. So this is also SP. What about this? One sigma, two sigma, and hydrogen means also sigma. So three sigmas means sp2. And what about this? 1, 2, 3 sp2. This one 1, this side 3, 4 sp3. Is this clear, everyone? Okay. Now the second question will be whether this molecule is planar or non-planar. Planar means what? See, when I say sp2 hybridization, you are saying trigonal planar. When I say sp, you are saying it as linear. So even if you say linear or a trigonal planar, that lies in one single plane now. That is perfect. But when I say sp3, what is its geometry? Tetrahedral. If it is tetrahedral, how they are? Like two hydrogen atoms like this in the plane, and one is like this, one is like this. Okay, are they planar? How many atoms are within the plane? See, if this is carbon, one atom this side, another atom this side, another atom this side, and one more atom like this. How many atoms are within the plane? 4. Plane means ఇందులో ఒక ప్లేన్ పంపియండి మీరు ఏదో ఒక ఇమాజిన్ ప్లేన్ చేసుకొని like this. See, my hand is what? Carbon atom holding 4 other atoms. Now tell me how many atoms are in the plane? 4. Arey, see, I don't know how to catch. Okay, we'll try this. Okay, see, this is the plane. Like you are taking one plane and you are passing like this. So carbon atom is cutting this atom and also this atom. What about these two? They are not dividing into two equal halves. Are you following? Yes, sir. Only this one, this one, this one. So how many atoms are within the plane? 3. This one, this one, this one. So 3 atoms are within the plane. Remaining 2 atoms are? Okay, you take cap after the class. Okay, how many atoms are within the plane? 3. 2 are not plane now, not in the plane now. So you can say tetrahedral means it's a non-planar. What is that? It's a non-planar. Got this? Yeah. So now the question in the book, if you observe, there are some questions. They will ask, which are the following molecules? All the atoms are in coplanar. Coplanar means co means 2 should be in the same plane. You just check. Hybridization must be what? Either sp or sp2. Then all of those atoms mostly in the plane. If it is sp3, non-planar. Okay, is this clear, everyone? Now you can do first, second, or some questions, whatever it is mentioned. Okay, next question will be like this ma. Look at here, everyone. C. Okay, like double bonds, like pi bonds are continuous now. I can write C, double bond C, single bond C, like this I can write. How do they differ, this 1 and 2? Pi bonds are alternate position, perfect. If they are alternate positions, you should say them as conjugative systems. What they are? Like conjugation today we studied now, like this pi bond shifts here, therefore here, see, it is shifting here means this carbon is losing the pi electrons now. What is the charge you are creating? Positive. If it is shifting here, already this carbon has 4 bonds. Now this 5th bond is coming means this should be moved here, like this. So what is the charge here you are generating? Negative charge. Like this, charge distribution takes place. What is this concept called? Conjugation. Okay, and this kind of systems are called conjugative systems. Next, look at this, hydrogen, 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 I am writing like this. What about these carbons, I mean pi bonds? these are like alternate positions, you should say them as conjugative system. These are continuous double bonds now. See, they are continuous or not? Here alternate, pi, sigma, pi. Here continuous. So these are called cumulative dienes. What they are? Cumulative systems. Cumulative dienes are cumulative systems. It means pi bonds are continuous. Okay, very important it is to understand. See, a pi bond is formed. See, first they will form sigma bond like this, and p orbitals like this now. They will overlap sidewise and will make a like this. They will make a pi bond. First sigma bonds like linear, like axial overlap. The next like this horizontal forms what? This is a p orbital of this carbon. This is a p orbital of this carbon. This is formed first sigma bond. After that pi bond. Is this clear? Okay. Now one more pi bond p orbital will be there. That will be perpendicular. First p orbital is like this. Another one will be like this. Okay. See, first one, look at this. Carbon, one bond. How many orbitals are there with one carbon? Tell me first. 4 orbitals. First of all, let us say this carbon making 3 sigma bonds. It means what is the hybridization? sp2. It means one more p orbital is remaining here like this. Yes or no? How many sigma bonds with this middle one? This side one, this side one. It means sp. Remaining 2 p orbitals are there. Yes or no? Are you getting what I am saying? That p orbitals, one is like this, one is perpendicular to this. It means 90 degrees. Like this you should write. Okay? Are you just imagine them. What about this one? 1, 2, 3. sp2, one more p orbital will be there. Okay. See, if this carbon p orbital and this carbon p orbital are overlapping and making a pi bond. That pi bond I have written over here. Next one, to the center p orbital, how these p orbitals are oriented? Perpendicular, no? So if they are like this one and this p orbital should be perpendicular and will make a bond. It means how they are, just imagine if this pi ring is like this, just imagine this pi bond is like this and this pi bond will be like this. Are you able to imagine what I am saying? This one, this pi bond, how they are? Perpendicular to each other. Are you getting what I am saying? Okay. Now, these hydrogens, if you observe, this is like this now. This hydrogen is one is at here and other one is like this. What about this one? Here, like this one and one is back side of this board. But what about this one? Above side of the board and one hydrogen is? Are they in the same plane? Not. They are not in the same plane. Are you able to imagine or not? చూపించడం కూడా చాలా కష్టం. Where I kept the pen. Okay. See, one ring I have kept like this and another ring is like this. Bangles are there? Okay. You just imagine you are keeping one bangle like this and one more bangle is like this. See, one ring is like this, one pi bond is like this. Another pi bond will be, give me. Another pi bond will be like this. Are you able to imagine how they are perpendicular to each other? Now, just imagine here one hydrogen is there towards you. Here, this side, back side, one more pi bond will be there towards my side. Okay? And what about this one? One is above side, below side. Now all these 4 groups, how they are? All these 4 hydrogens are in the same plane or different planes? Something like tetrahedral geometry you will get. Right now? So now cumulative dienes are planar or non-planar? Non-planar. Perfect. Cumulative dienes are now what? Non-planar. Once again, listen here. Cumulative dienes are what? Non-planar. Remember, these cumulative, these continuous double bonds are there now. They should be even number of double bonds. What I am saying? This pi bond should be even, then non-planar. What they are? They are non-planar. If they are odd number, what I am saying? Odd number. just imagine once again, this ring is like this pi bond formed is like this. ఇప్పుడు ఈ పై బాండ్ ఎట్లా ఫామ్ అయింది, ఇట్లా ఫామ్ అయింది. నెక్స్ట్ పై బాండ్ ఎట్లా ఫామ్ అవుతుంది, మళ్ళీ దీనికి పర్పెండికులర్గా అంటే సి ఇది ఇట్లా ఉంది కాబట్టి మళ్ళీ ఇది ఇట్లా వస్తుంది. అర్థమైందా? మళ్ళీ నెక్స్ట్ ఎట్లా వస్తుంది, పర్పెండికులర్గా వస్తుంది. మరి ఈవెన్ నెంబర్ ఉన్నప్పుడేమో దే ఆర్ ఎగ్జాక్ట్లీ లైక్ పర్పెండికులర్ టు ఈచ్ అదర్. బట్ ఆడ్ నెంబర్ ఉన్నప్పుడు ఫస్ట్ది లాస్ట్ది ఏమవుతుంది, జస్ట్ ఇమాజిన్ ప్యారలల్ అవుతుంది చూడండి. ఫస్ట్ సర్కిల్, ఐ మీన్ హారిజంటల్, సి వర్టికల్, horizontal, మళ్ళీ vertical. It means first one and third one side atoms are in the same plane. So it means if odd number of double bonds are there, odd number of continuous pi bonds, what they are now? Odd number of continuous pi bonds or odd number of pi bonds containing cumulative dienes. What they are? Odd number unte planar or non planar? Planar. Is this clear? Everyone అర్థమైందా కాలేదా? ఇప్పుడు దీని మీద క్వశ్చన్స్ ఎట్లా వస్తాయో చూడండి. A, B. Tell me, which of the following is planar? Just count number of pi bonds, that's it. If odd, planar. Even, that's it. Everyone got this?
Yes, sir.
Okay. Next one. What about isomerism? We have studied about structural isomerism in the morning class. What about stereoisomerism? What about stereoisomerism? Basically, it is of two types. How many types? One is geometrical, another one is optical. What is this? Geometrical and optical. So, geometrical isomerism means you have studied it as like cis trans, and one more is EZ. What is this? Cis trans and EZ. Next one, here optical isomers means here we have some terms like Enantiomers Diastereomers, okay, and the next one is racemic mixture. These are the terms to be known, okay. I will tell about all these things. Anyways, you just need to understand enantiomers and diastereomers first. Okay, first of all, cis trans means what? See, two carbons are there. In order to show geometrical isomerism, like cis trans in open chain forms, what I am saying, open chain, they should be planar. What they are? In open chain they should be planar. Planar means like sp2 hybridization should be there, not linear, not sp hybridization. What they should have? sp2. sp2 means trigonal planar, na? Okay. So now here, here, here and here, let us say AA, BB. See, same groups, same side of the pi bond. See, then hybridization in Tamma, sp2. This one also sp2. So this is trigonal planar like this if you compare. This is also trigonal planar. See, with overall molecule is planar or not? So in the planar molecule, if the same groups are on same side of the carbons, they are called cis. This is very basic. Okay. Now what is the angle you can expect between A and A? Something like this. 90 degrees now perpendicular. Okay. So cis means you should have 90 degrees. When I say, how they are now? See, exactly 180 degrees you can say. So these are called what? Same groups, opposite side, trans. Okay, up to here everyone? Okay, next one. You just tell me, what about this? Cis. Okay, fine. So you got something like cis trans isomerism, you got. Now, just one last example. What about this? you cannot decide. Here, yeah, here it is perfect, but what about this? With respect to this hydrogen and this hydrogen, you can say cis. With respect to this trans, we cannot decide, it is unable to decide. So no GI, no geometrical isomerism or no cis trans isomerism. Everyone clear with this? Okay, next example. What about this? It is not like that. The two groups we are comparing, one should be on one and another one on the next adjacent one. See, both of them are on same carbon, so here also you should not decide. Is this clear or not? చెప్తుంది అర్థమవుతుందా? Okay, next. What about this? You don't know about, we cannot give this cis trans isomerism, but we can give here EZ isomerism. What isomerism? EZ. What do we mean by EZ isomerism? Means there are some rules called CIP rules. What is that called? CIP. It means it is based on the atomic number. Which atomic number is highest here? The side groups. Iodine. That should be given as first priority. So on one carbon side, this side carbon, which is more priority group out of these two? Based on atomic number. If atomic number is same, follow atomic mass in case of isotopes. So out of these two, who is prioritized? 1. This is 2. This side also you tell me which is first prioritized? 1. This is 2. So more priority group side are on same side now. You should say this is Z isomer. What is this? So Z means zusammen. No need of remembering all these things. If it is good, if you remember, it is really good. So zusammen. Okay. Next one is tell me here. Which is prioritized out of these two? 1. These two? How do they arrange 1 and 1? So it should be called as E isomer. This is called entag again. Okay, so just remember, cis means what you know? Cis means same side. Like Z, cis Z, like pronunciation almost, you remember at least like that. Okay, zusammen means priority group should be same side. Don't think like always cis means Z. Always Z means cis. Don't think like that. మీరు గుర్తుంచుకోవాలని ఆ ప్రొనౌన్సియేషన్ లా గుర్తుంచుకోండి అంతే. Okay, there is no connection between EZ and cis trans. E isomer can become cis isomer or E isomer can become trans isomer. So don't compare like always if I say Z means it should be cis or it should be trans like that. It may become anything. Just give relative priorities. Here we are following purely what? Atomic numbers. More atomic number, first prioritized like that. Is this clear? Okay. First give the priority to the first 2 atoms of one carbon, go for the next one also. Clear everyone? Yeah. So now the question will be like this. Cl, I, Br, F. Okay, so between A, B, what is the relation? What about this? Huh? చెప్పండి ఇది ఏం ఐసోమర్? 1, 2. Here 1, 2. This is also Z na. So let me change this. Cl, I. Here it is 1, here it is 2. 1, 2. What about this? E isomer. E isomer. So now tell me what is the relation between A and B? కొంచెం కాన్షియస్గా ఉండండి. వాట్ ఈస్ ద రిలేషన్ బిట్వీన్ A and B? Let us say this is C. How do they differ? A and B. See, just check the bond connectivity. CFBr. CFBr. This side also I. Here also Cl. It means they have same bond, same chemical formula, and also same bond connectivity. Bond connectivity also same now, but they differ in the spatial arrangement of atom. Here I is above side, here I is below side. In the three-dimensional space, arrangement of atoms are different. So these are called as what? Stereoisomers. And particularly if I want specifically, I can mention it as EZ isomer. Perfect? Okay. Now what is the relation between A and C? Now what to check again? Just go with the atom to atom. Carbon, carbon, F. Here it is Br, here it is Cl. See, overall chemical formula is same. Overall chemical formula is what? C2F Cl Bri. Overall chemical formula is same, but bond connectivity is same or different? How do they differ? Position of halogen atoms. So now AC are called what isomers? They differ in what? A ki C ki bond connectivity same unda. అందుకే కాన్షియస్గా ఉండండి అమ్మా అని చెప్పిన. ఏకి బీకి బాండ్ కనెక్టివిటీ సేమ్ ఉందా? FBr. This side CLI, just differ in the spatial arrangement. So these are called stereoisomers. Now what about AC? See here, this side, here chlorine, iodine. This side iodine is fine, but instead of chlorine we have bromine. But overall chemical formula is same for A and C. Now what is the relation between A and C? Can I say that do they have same bond connectivity? If no bond connectivity is same, means they are not stereoisomers. They must be what now? Structural isomers. In the structural isomer, we have chain isomer, positional isomer, like the different are there now. So tell me particularly. Position of halogens are different. So you should say them as positional isomer. Do you got what I am discussing? Yeah. So tell me between BC. They are also? Got everyone got this? అర్థమైందా కాలేదా? Next. So you got EZ isomerism. Okay, one more thing here. See, they will give a formula like this. One last question on this. Okay. Like this. Now, number of possible isomers they will ask. Number of possible stereoisomers. Fast ma. See here one double bond is there now. Just imagine what about this side? One alkyl group is there, one methyl group. This side hydrogen is there. What about this side? Hydrogen. Out of these two, who is more prioritized? Hydrogen or carbon? This is 1, this is 2. Out of these two, who is prioritized? Carbon or hydrogen? 1, 2. So can I give here EZ, not systems, EZ I can give now? Yes or no? Tell me whether it is E or Z. Same like least periodic group C. These are opposite. So I can say this is E. Okay, at what position? See 1, 2, 3, 4, 5, 6, 7, 8. So 2E I should say. Can I say 2E? Next, fourth position again we have double bond. How it is again? See this side to the carbon, this side already we have one thing, and this side hydrogen. To this carbon, this side alkyl group is there, this side hydrogen. How they are oriented? Opposite. So again it is also E. So 4E. Similarly you tell me for this one? 6E. Okay, now what is the name of this compound becomes? Like this, after writing, you just mention how many carbons? Octa. 3 double bonds now. Octa. Triene. Got this up to here? Now what is my question actually? Number of possible stereoisomer. Like you are saying now, here EZ, here also EZ, like that. If one stereo, like one center is there, which is giving EZ isomerism, it means that is one stereo center. Ikkada EZ isomerism అని మీరు నేమింగ్ ఇస్తున్నారు కదా. So this center is considered as one stereo center. Like that, how many stereo centers are there? 3. So number of stereo centers is equals to 3. Number of stereo center I am indicating with symbol n. Then what is my question? Number of possible stereo isomers. This is equals to 2 power n. What is it? 2 power n. So it becomes how much now? 2 power 3. 2 power 3 means 8. So how many stereo isomers are possible like this? 8. Exactly 8 ఎలా రాస్తాం సార్ అని అంటే చూడండి, I can write 2e 4e 6e or 2z 4e 6e or 2e 4z 6e. ఇట్లా పాసిబుల్ నెంబర్ ఆఫ్ స్టీరియో ఐసోమర్స్ హౌ మెనీ పాసిబుల్ దే విల్ ఆస్క్. అర్థమైంది ఇది ఎట్లా రాస్తున్నాం అనేది? అన్నిటినీ ఈలాగా రాయొచ్చు, అన్నిటినీ జెడ్ లాగా రాయొచ్చు, ఒకదాన్ని ఈలాగా పెట్టి మిగతా వాటిని అట్లా. హౌ మెనీ పాసిబుల్ స్టీరియో ఐసోమర్స్ ఆర్ దేర్ దే ఆర్ ఆస్కింగ్. వాట్ ఈస్ ద ఫార్ములా టు యూస్? 2 పవర్ n. n వాల్యూ ఇండికేట్స్ వాట్? అర్థమైందా కాలేదా? ఓకే, అరే ఇంకా మీకు ఇంకా క్లారిటీగా రావాలనంటే యూ జస్ట్ టెల్ మీ with this formula how many stereoisomers are possible? How many stereoisomers are possible? How many stereo centers are there? Like you are saying this is cis na, means with the same formula we can also get trans also. Yes or no? So stereo centers are how many? Stereo centers ante ila 1 ante 2 power 1, that means 2. What are these two isomers now? One is cis, another one is trans. అట్లా ఈ మాలిక్యూల్కి ఎన్ని అని అడుగుతారు. వాట్ టు యూస్? 2 పవర్ n. ఐడెంటిఫైయింగ్ n మీన్స్ వాట్? నెంబర్ ఆఫ్, జస్ట్ నెంబర్ ఆఫ్ డబల్ బాండ్స్ అనొద్దు. కొన్ని డబల్ బాండ్స్ దగ్గర ఈజెడ్ కూడా ఇవ్వలేం, సిస్టాన్స్ కూడా చెప్పలేం. అప్పుడు దాన్ని కన్సిడర్ చేయాలా, కౌంటింగ్ తీసుకోవద్దు. ఫర్ ఎగ్జాంపుల్ నెంబర్ ఆఫ్ స్టీరియో సెంటర్స్. ఇప్పుడు ఈ కార్బన్ గురించి చెప్పండి. దిస్ ఇస్ ఈ, ఐ కెన్ సే. వాట్ అబౌట్ దిస్ వన్? ఈజ్ దిస్ ఎ స్టీరియో సెంటర్? నాట్ ఎ స్టీరియో సెంటర్. వీ కెనాట్ గివ్ ఈజెడ్ హియర్, వీ కెన్ ఓన్లీ గివ్ హియర్. సో 2 పవర్ 1. సో 2. One is E and another can be. Do you got what I am discussing here? Everyone? Okay. So this is the thing you need to know about what? Geometrical isomerism. Next one is optical isomerism అని చెప్తున్నాను కదా. Okay. See, when we have some time, I will show you one very good example. But just now listen this. See, a carbon with 4 different. See, what is the valency of a carbon? 4 valency na. Carbon with 4 different groups. See, 4 sigma bonds are there means what is the hybridization you will get? Tetrahedral geometry. So here it should be like A, B, C, D. If 4 different groups are present on the carbon, then that carbon is called chiral carbon. What carbon? Chiral carbon. Okay. Now how this orientation? Like 2 groups will be, one is above the plane, another one will be below the planes, and 3 groups are within the plane. ఇప్పుడే చూపించా హ్యాండ్ విత్ కార్బన్, ఇటు ఒక పెన్ పెట్టి ఇట్లా చెప్పి ఏమని చెప్పిన, హౌ మెనీ ఆర్ విత్ ఇన్ ద ప్లేన్ ఐ టోల్డ్ యూ. వాట్ ఆర్ ద థింగ్స్ హియర్ ఇన్ ద ప్లేన్? A, C, D are in the plane. This B is towards you, towards the observer, and C is away from you, like back side of the plane. Like this you should understand. Okay. So now you just take a mirror now. What you are taking? Mirror. What you are taking? Mirror. Take that mirror and keep here. What happens? So now tell me, if you keep something near to the mirror, it will looks like far from you. Okay. Now above the plane become below the plane, below the plane become above the plane in the mirror. Yes or no? So now this will leaves within the plane only, like A, C, D. But what about this? It becomes above the plane unte emavutundamma. So I should write here, this becomes, do you got what makes the difference here? So now these 1 and 2 called non-superimposable mirror images. What do we mean by non-superimposable? Just imagine here I have a mirror, na? My hand is this one, first molecule is this hand. Now mirror image of this hand means like this only, na? Same, like this only you will get. Idi mirror images na kada. Just imagine there is a like what is this? Mirror. Okay, one hand and its mirror image. Now remove that mirror. Now you bring this hand, keep it on this molecule. See, are these merging to each other? See, my little finger here, it is thumb finger. So it means this is concept is called non-superimposability. What is this called? Non-superimposability. See, sir, what do we mean by superimposability? Means like, see, if it is merging like this means superimposability. But see, if you bring this sign keeping on this, okay. So same thing, you just try to bring this and keep it on this. Imagine this is a molecule and you are bringing on, keeping on this. What happens? Tell me. DD merges because same plane. CC also merges, same plane. AA also merges, same plane. But what about this? Here B will be above the plane, this B will be below the plane. అంటే ఒక B ఇట్లా పోతే ఇంకో కింద ఉన్న B ఇట్లా కింద ఇటు వెళ్ళిపోతుంది. అంతేనా? Are you able to imagine? So can I say this is superimposable or non-superimposable? Non-superimposable. So these non-superimposable mirror images are called enantiomers. What they are? Enantiomers. So once again tell me, what is the definition of enantiomers? With very clarity, stereoisomers which are non-superimposable mirror images are called enantiomers. Okay. So now give me example for this. So what is the thing you need to identify first? A chiral center. Chiral center means carbon with 4 different groups. Okay. So tell me, how many chiral centers are there in the given molecule? Chiral centers ఏమైనా ఉన్నాయా? అరే చూసి do we have any chiral centers or not? What I told you? See, this carbon with 3 hydrogens means that these are not the mirror. What about this carbon? This is one methyl, another group, some big group is there, and chlorine is there. One more is what? And 4 different groups unnatega. So can I say this is a chiral center? Yes. You getting what I am saying? What do we mean by chiral center now? They will ask you how many chiral centers are there in the given compound. Okay, what about this one? These 2 groups are same now, so you should not say this is a chiral center. Are you able to identify? Okay. Now, one chiral center is there means definitely have its mirror image. If this is one enantiomer, its mirror image also? Yes, you got what I am saying? If there is one chiral center, it will be definitely having its mirror image. Like that, if there is one chiral center, how many stereoisomers are possible? ఇప్పటిదాకా EZ చెప్పినప్పుడు ఏమని చెప్పినా, if there is one E isomer possible, definitely we can get Z isomer. Similarly, if one chiral center, one isomer is there means, one chiral center is there means, that compound and its mirror images. So total isomers possible with one chiral center, 2. Okay, so that isomers are called R and S. For example, if this is R isomer, its mirror image is called, if this is S isomer, its mirror image is called R. It means, see, this is an R isomer, I am saying now. What is the enantiomer of this R isomer means what you should say? S. If this is S, its enantiomer become R. Do you got what I am saying? Yeah. So with one chiral center, how many stereoisomers are possible? Like 2 power n, 2 power 1. One is R, another one is You got what I am saying here again? Yeah. So now tell me for this. Fast. How many chiral centers are there? 2. What are those? This one. This one. What about this? No. So 2 power 2. So 4. So what are the 4? If I ask, what is your answer? What are the 4 isomers you should say? Like it can be R comma R, it can be R comma S, or it can be S comma R, or got the concept now? Okay, like this. Now tell me number of possible stereoisomers. What to do? Number of possible stereoisomers. Okay. Fast. How to say this? This is one chiral center. Chiral center also called as asymmetric center. Please try to write all these things in the short form, whatever the way you can, or chiral center. So here one chiral center is there. What about this? This is like geometrical isomerism. Ez is possible. See, stereoisomerism of 2 types. One is optical, another one is geometrical. See, here we have geometrical isomerism. Here it is optical isomerism. Consider both of them. So total number of isomers possible, how many? Stereoisomers. Here one center, here one center. So you just 2 power 2. It means 4. So what are those 4 means? Here it can be R, it can be S, here it can be E, Z. Like that possible number of isomers are how many? 4. Clear everyone? Okay. Remaining thing we'll discuss in the next class. Okay. You can make a note.